start off our class on integral calculus, I'm going to assume that you know the basics, like the fundamental theorem of calculus, how to take basic antiderivatives, and how to use U substitution, for example. But a couple of basic things that I won't assume that you know how to do are how to find the area between two given curves, and then also something called the net change theorem. So I'll talk about the net change theorem first. The net change theorem is really just the fundamental theorem of calculus. One version of the fundamental theorem says if you take the integral from a to b of f prime of x, you can calculate that by just finding the original function f and evaluating it at b and at a and doing f of b minus f of a. So, for example, if you think of f as position or height, then the rate of change of position or height is velocity. So this fundamental theorem is saying if you integrate the velocity from time equals a to time equals b, that's the same thing as if you take the position at b minus the position at a, which is just the displacement or the net change in position. Another example is if the function f were representing population. So if you had a function that represented the rate of growth of population, so if you integrated the derivative of the population from the year t equals a to the year t equals b, that's the same as just calculating the original population at t equals b and t equals a and subtracting, which is the net change in the population. So because of this, just looking at the fundamental theorem this way is sometimes called the net change theorem. So that's one thing that you need to be aware of. The other thing, finding the area between two curves, is also pretty simple. Here, if you think of two functions that are both positive, so sitting above the x-axis, and one is above the other one, then if you take the area between the top one and the x-axis, and then you subtract off the area between the bottom one and the x-axis, then you're going to get the area between the top one and the bottom one. And the same thing happens if the top one is positive, but the bottom one goes under the x-axis. Then if you do the area under the top one minus the area between the bottom one and the x-axis, then when you subtract this area that's under the x-axis, that area was considered negative when you take the integral, but then you subtract that negative number and it's adding that area under the x-axis to the area that you had above the x-axis. So it works in that case as well. The same calculation, you can just take the integral of the top one minus the integral of the bottom one. And it turns out that works no matter how the two functions are situated, as long as one stays above the other one for the entire range that you're looking at, from say x equals a to x equals b. So you can always integrate, you can always find the area between two curves like that. But sometimes your picture may be oriented in such a way that it's easier to integrate from left to right instead of from bottom to top. So if you do it from left to right because of the way the curves are situated, then you're going to integrate with respect to y instead of with respect to x. You could also just change the roles of x and y in that situation, and that would take your integral that naturally goes from left to right and switch it so that it goes from bottom to top. So you can either integrate with respect to y going left to right, or switch x and y and just integrate with respect to x.